All right, welcome back. We're going to take a look now at the cosine rule. This is for those situations in non-right angle triangles where we don't have the basic criteria that we need for a sine rule question. And sine rule, of course, is applicable when we have a known side length and its opposing or opposite angle known in degrees. So these are the two situations where neither of those apply. Now you can see here, this particular one doesn't at first appear as though it's eligible for sine rule, but a simple subtraction of those angles. Of course, we remember that the sum of the angles in a triangle is held fixed at 180 degrees. So if you know two of them, you're really not very far off from finding the third and unknown one using subtraction of the 45 and the 30 degree angles there from 180, and then you're off and running with the sine rule again. So we're not dealing with situations like that. The situations we're going to be dealing with are ones where one of the two following things is happening. You either know all three side lengths and you don't know any angles at all, in which case the cosine rule will help us find that any of the missing angles that we like. Or the alternative is when you have two side lengths which are known and they're trapping or containing is the actual technical word for it in geometry. They contain the angle A. Now, contained angle means that you know an angle by its size, the angle size, degree size, and you know the two lengths that trap it, like holding it between two of your extended fingers, making kind of an angle there. In which case, you can use any one of these formulas. Now, these formulas are identical, except that they've got interchangeable parts. The one thing to bear in mind is this, that the side length that's over here isolated on the left must be the companion partner of the one that's in the cosine on the other end of the formula. Over here, you can see it's side B, so over here it's angle B. Over here it's side C, so over here it's angle C. And if you've got that, then any one of these variables can be solved for. Right, here's how we can look at it. Now, the formula is in our formula booklet for the course, and it comes in two different formats. But the truth is that we usually use this one a lot more, especially because of the technology that's available to us. And I'm specifically thinking about NSolve on the TI Inspire calculator. That means you can nominate any variable for solving, no matter where it is. This is kind of old-fashioned here. This is the version of the cosine rule that we'd use. It basically says the same thing as this one over here, except that it would be used for when you know all three sides and you're trying to find an angle. Back in the days pre-GDC, we would use this a lot because it was handy to have the cosine of the angle isolated on the left side. It made it just a bit more speedy toward finding an accurate solution. But like I say, now with NSolve, there's absolutely no need to have that at all. Let me show you what I mean. Here's a case of a question where all three side lengths are known, 14, 12, and 7. All right, our first problem is, of course, that this triangle is referred to in words, and we need to come up with a diagram where we can store relative triangle measurement information and not lose track of it, not try and hold everything in our head simultaneously. That's sort of just begging for a mistake. So what I'm going to do, I'm going to get a ruler out here and I'm going to draw a line that's 14. Check, did that. I usually start with the long one. On top of that, I'm going to draw a line that's 12. So I've marked off 12 over here on my ruler. I'm going to take that line and tilt it up. And then I'm going to tilt it up just enough so that the gap that remains over here looks like it should be approximately 7. Now let's see how close I did. So I highlighted a blue line there that's 7. I tilted up and sure enough, there it is. Is it 100% accurate? Probably not. It doesn't need to be. It only needs to be a representative where we can store information and not deceive ourselves. We're going to confuse ourselves because of our diagram. Okay, I'm going to put the information in here. And notice that it said side length A was 14, and 14 has to sit across from angle A, so I'm going to list that over here. 12 was side length B, and it must sit across from angle B. And lastly, side length 7 has to sit across from C has to sit across from angle C, and so we got it. Now, what are we asked to find? Find all the angles. My advice is always to find the largest one first. It keeps you out of trouble. I can't really elaborate more right now, but there are situations where not doing it in this order can lead to some really suspicious moments. So what I'm going to do is I'm going to use this first version of the, by the way, I know that angle A is biggest because it sits across from the biggest side length over here. It has to be the biggest angle because it has to spread the widest to accommodate the largest possible side over here. Now, using this formula, what does it look like? Well, This is A, this is C, this is B. So I can put all those bits of information in these spots here, and there's the one thing I'm looking for. So I'll use NSOLVE to maximum efficiency and say 14, that took place of A, 12 took the place of B, 7 took the place of C, the 2 is part of the formula, 12 is B, and I just put A. Now I know that little a technically refers to a side length, but when I type in a capital letter on our Inspire, it automatically reverts it back to a small one. You just got to keep track of what you've done. And it tells me that that angle must be 91.0232 degrees. That's it, that's done. Now, do I need to preserve the accuracy of that angle? Well, the short answer is no. Because what I'm going to do now is I'm going to repeat that process because it said find all the angles or find the angles. And I'm going to go after the next biggest one. That's the next biggest side. So B is the next biggest angle. So I'm going to redo this now. But now you see what I've done is I've replaced the numbers here. A has drifted back into one of the spots on the right side, here and here. C has retained its location. And B now goes here because that's the angle I'm looking for. And it says it's 58.98 degrees. So if I rounded off 3 SF, that would be 59.0. And lastly, I can go ahead and find, well, actually, now that I think about it, you could just take these two angles, add them up, and figure out how much short you are at 180 and just do subtraction. But since we've got NSOLVE all warmed up anyway, we can go ahead and figure out that this is going to be 30.0 degrees, which is this rounded off to 3 significant figures. All right, here's a worded problem. It's supposed to represent some sort of reality-based situation. So you've got a completely inaccessible measurement across a lake. So what do? You take a spot over here as an observer. You measure the angle that you span to get across from one side of the lake to the other side of the lake, and you figure out these distances, probably by measuring them with some sort of device or pacing them off, who knows. This is a contained angle situation. So I'm looking for a side length, which I can do. I'm going to go ahead and go to the next one here. I'm going to call that A. Once again, here we are. Now, in this situation, what I'm trying to look for is the A here. And now, I've often said that if everything on the right side is numerical, you don't need to use NSOLVE. But notice that over here, it says A squared, not just A itself. So if you were just to compute all this stuff that's over here on the right side of the formula, you would have the value of A squared, which is not the end of the world. You can take the square root of that answer and find the value of A, which is this length over here. But you know what? Let's go ahead and use NSOLVE. It's going to be much quicker, and it will take you directly to the answer without, notice it says A squared is isolated here, but we're looking for A, and it tells us that that lake must be 307 meters across. All right, let's try another one here. There's 3 towns, A, B, and C. They form a triangle. The side lengths are 8 for BC as diagrammed, 13 for AC as diagrammed, and a contained angle. Find both angles A and B. Well, this is a classic cosine rule question because we've got a contained angle. 50 is trapped between the 13 and the 8. So, wait a second, we're looking for angles A and B. That's interesting because you see this one here, there's no cosine rule for finding an angle. So what we're going to have to do actually is not use the cosine rule directly. What we're going to have to do is we're going to have to do something temporarily to find another side length, because once we do that, that will unlock this problem. There's no formula. We can only find the length across from a contained angle. We can't find another angle using the cosine law, not given that information of the contained angle. So what I'm going to do now is I'm going to find side length C first. I chose C because it's across from the angle C, and I can see that it's 9.96495. Now, this side length is not ready to be rounded off because we're going to be using it in a subsequent part of the problem. So I'm going to have to leave it unrounded. Hopefully, I'll be able to refer to this in my GDC as the previous answer, and that way it's real, heightened accuracy will be preserved. Notice that I wrote it down actually. On my GDC, I said, what is the answer? And they gave us way more precision than it actually computed the first time. So when I go ahead and I'm going to use sine rule now that I know this, because what's happened is in this problem, it's morphed or evolved into one where I do know a side angle partnership. And that allows us to go ahead and find either of these angles that we want to find. Now, normally the sine rule would say this: the sine of an angle, unknown angle, like at A, sits across from 8. The sine of 50 sits across from this previous answer here. And so I'm going to go to my GDC and notice I put answer in here and that means this answer that's not rounded off by the calculator will be used. If I do that and I solve for it now, it tells me that the angle at A is, according to the rules of 3 significant figure rounding, 38.0 degrees. I can add that to my triangle, and they wanted to find the answer for B. Well, now that I know 2 angles, I'm going to go ahead and use subtraction and see that it's 92.0 degrees. Well, all right, that's it basically, I think, for this section. Not a very difficult formula to use. You basically just want to rule out first that sine rule can't be used. Sine rule is used a lot, but you can only use it when you've got a side angle partnership. Cosine rule picks up all the scraps after that. It can be used for all situations. Notice that we've got the use of the word bearing a little bit in here. You have to get comfortable with that. And there's a nice little chunk of questions here. And there's our list. We're in section 2B right now, and I'd like you to do questions 1, 2, 3, 4, and 5. Okay, good luck.